This video is about hyperbolic functions, specifically hyperbolic cosine. Here we have three lines, three functions. The blue one is simply a combination of the two red ones. And each of these red ones are e to the x, half e to the x, and half e to the minus x, respectively, below and above the axes. Should label these in a second. There we go. And either the addition or subtraction of these two can give you the hyperbolic function for sine or the hyperbolic function for cos. Today we're only going to look at sine, and sine is the subtraction between these two functions. And that would be the blue line here. A half of e to the x minus e to the minus x. This is known as sine hx, or shine, you can say. Likewise, if we just have a line of y equals x simply here, and we reflect this line, we'll get an alternate line. This purple line here, that's going to be, forgive me if it's messy, that's going to be our arcsine. Today we're going to show how you rearrange sine hx and you can derive arcsine. Let's continue. So to start off on the right track, let's say sine h or shine of x equals y. So we have y equals a half e to the x minus e to the minus x. Now let's rearrange so we can make this 2y equals e to the x minus e to the minus x. Now let's multiply both sides by e to the x. So we can get rid of this minus here. We don't have to deal with that. But there's also another reason why we do this. And those of you with sharp eyes will be able to see exactly why. This equation on the bottom, first let me make some space up here again. This equation on the bottom that we now have is reminiscent of a very popular and common form in maths, really, especially in graphing. This can be written as a quadratic. If you think about it, e to the x is common in two of these terms, and the last one just being minus 1, a constant. So we can rearrange to make an overall quadratic where e to the x squared minus 2y e to the x minus 1 equals 0. Now, with this information, we can now apply the quadratic formula accordingly, with our a over here being 1, our b over here being minus 2y, and our c over here being minus 1. So if you remember the quadratic formula, we have minus b plus minus b squared minus 4ac all over 2a, and all we have to do is plug these numbers in, and by doing so we'll get something like 2y plus minus square root of 4y squared plus 4 over 2. You can see here we can factor out the 2. So that will cancel down. We won't have any more 4's in our surd over here. And that will just become a 1. So our final reminiscent answer is this. But let's tidy it up. Y plus minus square root y squared, don't forget the plus 1. So after factoring out a 2 from our previous simplified quadratic, we now have this being equal to none other than e to the x, because in this case, this quadratic, our e to the x was essentially our x. But now, to complete the whole process, we can just substitute in our x for the e to the x, our y's for the x's respectively, and we also have to add a log to get rid of Euler's number there. Replace the y's, and there you go. There's the equation for arcsine hx, or arc of shine of x. Thank you for watching the video, and leave a like and subscribe.